Hello, everyone. Thanks for joining this webinar today. Today's webinar will cover changes coming to USGS water data APIs. Before I hand things off to our speakers today, I'm going to give a brief overview of Quasi while folks are still logging on and getting settled. Oh, okay. Can you still see my slide? Cool. All right. My name is Julia Masterman. My pronouns are she, her, and I am the Science and Education Outreach Coordinator for Quasi. Quasi is a consortium of universities for the advancement of hydrologic science incorporated. We're a nonprofit organization funded in part by the National Science Foundation, and our mission is to empower the water community in advanced science through collaboration, infrastructure, and education. Our infrastructure includes data systems. Quasi hosts a data repository for water science data, HydroShare. By providing the support and infrastructure, Quasi can help researchers formulate and execute their data management plans, be effective data stewards, and meet the requirements of funding agencies. Quasi also provides educational opportunities and infrastructure for student support. These include workshops, a summer institute for graduate students, webinar series and events like this one, a virtual university, and more. Both our data infrastructure and educational opportunities are designed to enable collaboration and interdisciplinary work. There are a few upcoming deadlines I want to point you towards and some things that are coming down on Quasi's calendar. We'll have another webinar series also with USGS beginning in September, focusing on the National Water Availability Assessment. Registration is open for that now. We'll have another webinar series also beginning at the end of this month. This one we're working with the AGU Hydrology Section Student Subcommittee, who have put together a number of really fantastic panels focusing on different important topics for professional development and other topics to support early career researchers in the water sciences. So some topics for the upcoming series are listed there, but including reframing research language for impactful and relevant broader impact statements, highlighting skill sets for careers outside of academia, expanding funding landscape, non-federal funding opportunities, and leveraging AI and data science in hydrology. Another announcement, applications for our snow measurement field school will be opening in just a few short weeks. This year, we're excited to host our 8th snow school this year in Colorado. It'll be the first full week of January 2026. This is a really popular program, so if you're interested in applying, be sure to get your application in soon once applications open. And finally, join our mailing list and connect with us. This information is here, but it'll also be posted in the chat in just a moment. All right. So today's webinar, as I mentioned earlier, is on changes coming to USGS water data APIs. A huge thank you to our speakers at USGS for taking the time to join us today and to give us these very important updates. A few logistics as we get started here. This webinar is being recorded and will be posted on the Quasi YouTube channel. Secondly, we ask that you use the Q&A functionality to submit questions to our speakers. Please feel free to add questions at any time and upvote any that are especially of interest. We'll do our best to get to as many as possible. Finally, we expect that all involved with Quasi Cyber seminars uphold the Quasi Code of Conduct and promote and maintain a professional, considerate, respectful, and collaborative virtual environment. And with that, I will pass the mic. Thank you so much.
Yeah, thank you so much for having us. Let me try and get my screen set here. And so hopefully folks are now seeing the intro slide and nothing else. Thank you so much for having us. Perfect. Thank you so much for having us today. My name's Mike. I'm the product owner for Water Data APIs here at the USGS Water Mission Area, joined today by my colleague Elise, who's a data scientist with our computational tools team. And we're here to talk about changes coming to USGS Water Data APIs. Now, here at the USGS, we have a suite of products and services which provide publicly accessible water data for the nation and which have been sharing our nation's water data on the internet for decades now. Unfortunately, over the span of those decades, the systems that currently exist to share this data have become somewhat outdated, And as such, we're currently engaged in a long-haul mission to modernize our systems, expanding the accessibility and usability of our nation's water data. We are extremely excited by these modernization efforts, but we want to note that we are moving forward with a lot of gratitude for the systems that we are replacing. The work that we're doing today wouldn't be possible without the legacy established by these existing systems. We also want to make a point of thanking all of the USGS partners and cooperators, including those here on this call today, who make our observation network possible, because what we're doing just wouldn't be possible without your support. Now, you might be familiar with Water Data for the Nation as the flagship product that shares USGS water data. Water Data for the Nation provides maps, graphs, tables, and other graphical elements that let you explore and interact with USGS water data, typically in your web browser. Today, we're going to be focused more on the left half of the slide and our other offerings for how you can access USGS water data. Specifically, we're going to be talking about our water data APIs, which provide access for repeat or automated or bulk downloads of data in machine-readable formats. And we'll be talking about our computational tools, which are software packages for R and for Python, which provide access to data from these APIs and tools for working with it more after it's been downloaded. Specifically today, we're going to be talking about changes coming to the water services family of APIs. These include the endpoints that provide access to continuous sensor measurements, daily values, discrete field measurements, and metadata about monitoring locations. These APIs have been providing access to USGS water data for over 15 years and power a large number of tools in addition to providing direct access. For instance, these APIs support tools that the USGS provides, like our National Water Dashboard and our monitoring location pages for exploring real-time conditions across our observational network. Our data also comes from these APIs to support other products maintained by other federal agencies, including a number of products from groups like the National Weather Service, Army Corps of Engineers, Bureau of Reclamation, National Park Service, and plenty of others. We also know that our data is being used at plenty of state and local government levels, as well as by a number of private organizations for their own data dissemination products, including a number of commercial tools. We are extremely excited about all of this use of our data, and this usage has been growing. Over the last 5 years, traffic to water services has more than doubled to the point where we're now serving more than 2.4 billion requests per year. That's 62 terabytes of data going out through water services in a given year to more than 10.5 million distinct IP addresses. So what we view as our total user base. This is incredible. We are so grateful that so many people find this data useful. Unfortunately, these APIs have become really difficult for us to maintain over the 15 years that they've been in operation. In particular, water services depends on out-of-date software running on out-of-date hardware, which means that it's become really difficult for us to maintain and expand upon these APIs to provide additional types of data and additional services. As such, in 2024, we started a project to release new modernized alternatives for these APIs. And so today we want to talk about what you can expect from this next generation of water data APIs. We're going to highlight what you can expect from the new APIs, when you'll need to migrate to them from water services, and hopefully highlight some features of the new system that you can look forward to as well. We'll also touch on some changes coming to our computational tools packages as they themselves migrate over to support these new endpoints. Now, in particular, today I'm going to be discussing 4 of the endpoints on water services. Specifically, I'll be talking about our instantaneous values or IV service, daily values or DV, groundwater levels or GW levels, and our site service. The statistics service on water services has been modernized separately with an eye towards better supporting the website's use cases. And as such, it's not exactly covered by the information I'm sharing today. But you can follow this link to the documentation for that new modernized endpoint. The samples data service, meanwhile, was modernized in 2024. So if you migrated from QW data over to the new samples data API, there are no changes coming to that API as part of this work. And so with all of that preamble out of the way, what can you expect from the new APIs? Well, first and foremost, the new APIs are going to be implementing what's known as the OGC API Features Standard. This is a widely adopted standard that specifies an API interface and a response object format, which brings significant interoperability benefits. There's a lot of tooling out there that works natively with our new APIs because we're adopting this widely known standard. In addition, because this is a widely used standard, hopefully these new services are going to be easy to integrate into your existing workflows because they're going to look and behave similarly to other services you might already be interacting with. However, that change to use the standard does mean that there are going to be changes in how you build queries and in the response objects that you get back from our system. And so to walk through those changes to how you build queries, I think it's useful to walk through an example query. This is a query to our legacy daily value service on water services. We're querying our DV or daily values endpoint for a single site of data for the past day. That's the P1D in the string here, and for a single parameter code. And we're also specifying that we want back the JSON response object. The equivalent query to the new APIs looks like this. Now, the first thing you notice is that this query is longer. Part of our general trend with these new services is that we are removing as many abbreviations as possible and moving towards plain language where we can to try and make queries more explicit and more readable. Our goal is that you should be able to understand exactly what's being requested from the query string when you find it in someone else's code. But otherwise, these queries are built very similar to each other, and we can walk through them element by element. The first big change is that the new APIs don't live at water services anymore. Instead, our new endpoints all live at api.waterdata.usgs.gov. The specific endpoints we're talking about today then have a slightly longer path to them. That's /OGC-API/v0/collections. The next part of our URL specifies the type of data that we're looking for. So rather than looking for data from the DV endpoint, we now call the daily endpoint, which is part of that change towards more plain language with fewer abbreviations to make these queries more scannable. The big exception to that pattern is that our next argument changes from format equals JSON to F equals JSON. That's a change that's due to the standard that we're using, but our other parameters generally follow the pattern that I'm talking about. Instead of specifying that we're looking for sites, we specify monitoring location IDs that we're looking for. This uses the site numbers that water services used, but also adds an agency code to our query argument here. We make this change because we have a lot of data that's furnished to us from other agencies, other people collecting data, which might use identical monitoring location numbers to other sites in the network. By adding this agency code, we're able to create unique identifiers for each monitoring location that we're interested in. We then add our time argument here using the exact same syntax as we used on the legacy system to specify that we're looking for the most recent day of data. And then last but not least, we add our parameter code argument changed from parm cd. The thing I'm trying to emphasize here is that this query looks very similar to the one that we would use on water services. We aren't changing anything about the data that you're working with. It's the same building blocks, the same concepts that you're used to, but a slightly different naming convention and a slightly different interface to specify which data you're looking for. The bigger change with the new services then comes in the response object that you get back after you run this query. Running this query against water services returns a JSON object that looks like this. Now, when we do user interviews, the legacy JSON gets a lot of complaints. Folks tell us that it is very verbose, very chatty, very bloated. It's a very complex JSON object, which has a lot of different levels of nesting and tends to use the word value a lot, which makes it really difficult for folks to work with and really difficult to extract the data that you're actually looking from this larger piece of information. In fact, it's so big I had to split onto two slides here. The response that you get back from the modernized services is going to be a much simpler JSON response object that is much slimmed down from that more complex object. It's also a GeoJSON object, which means that a lot of software will automatically be able to read it. A lot of spatial software will be able to load these response objects and work with it automatically. But it's also really easy to turn this into a table, in my experience, in R, in Python, in whatever language I'm using to then analyze the data downstream. Now, this is also a much smaller object, which means that it does download faster, but it also is smaller because it includes fewer fields than the legacy object did. I've put those fields on this slide in light gray for fields in the legacy object that are no longer returned. Many of these fields are things that aren't going to be missed. For instance, we no longer tell you the name of the server that processed your request, but some of these changes are going to be more impactful. In particular, the data endpoints, daily values, continuous values, no longer return as much metadata about the monitoring location or the parameter code associated with an observation. We're making this change because the vast majority of requests to our APIs come from people who are looking for the most recent observations for a known set of parameter codes at a known set of monitoring locations. As a result, those users, when they're making this very high volume of requests, are constantly downloading metadata about the monitoring location, about the parameter code that hasn't changed since their previous request. That means that we spend a lot of time sending out data that immediately gets thrown away by end users, which means that we spend a lot of wasted computation and a lot of wasted network sending that data to folks who aren't looking for it and don't need it. By removing it from these data endpoints, we're able to increase the number of requests that our servers can hold in order to adjust for the increasing usage that we're seeing on these APIs. We also wind up cutting down how long your download takes by returning less of this extra information with every single observation. Now, that's not to say that this data is going away, though. Instead, these data endpoints have keys that you can use to look up the relevant metadata in other endpoints. So for instance, the daily values object has a time series ID that corresponds to our new time series metadata endpoint, a monitoring location ID that corresponds to our new monitoring locations endpoint, and a parameter code that corresponds to our parameter codes endpoint. You can use these keys to look up the metadata that you're interested in once, rather than downloading it with every single request, and use that to construct the full data set that you are interested in from these services. We describe this as being like a set of building blocks that you can use to build your ideal data set at the end, and do so in what is hopefully a more efficient manner for both you and for our systems. Now, all of these new endpoints live at api.waterdata.usgs.gov. And at this point, I should mention, every link that I'm showing in this presentation is live. You can go to any of these and explore these resources. I'm not going to be showing anything today that's not currently released. And so on api.waterdata, you'll see the endpoints that I'm highlighting today, including daily values, monitoring locations, latest continuous values, time series metadata, parameter codes, all of these various endpoints, as well as other endpoints such as our water quality services and statistics APIs. This website, api.waterdata, is a big tent that provides a catalog of all USGS water data APIs. Additionally, on api.waterdata, you'll find documentation about each of these endpoints, a centralized catalog of long-form tutorials and examples that you can use to help build queries and understand how to work with these systems. The endpoints that we're talking about today are all collected under that OGC API key, which contains a lot of long-form tutorials and worked examples about how to work with the new APIs. You'll also find information here about how to make more efficient queries and more complex queries, as well as a migration guide for migrating your existing workloads over to the new services. The tables in this migration guide lay out every field that was returned by the water services APIs and the equivalent field in our new services, so that hopefully we can help you effectively find and replace any calls to water services in your existing workloads with their modernized alternatives. This is a living document that we continue to update as we continue to release new endpoints that we hope is a useful resource for transitioning over to the new services. The last resource on api.waterdata I want to highlight is our signup page, where you can access an API key for these services. Our new APIs implement rate limiting, which means that if you make more than a certain number of queries per hour, you're going to start getting error messages until the next error when your limit resets. This limit is currently set at about 100 requests per hour per IP address, which, if you work in an office with other people who also access these APIs, is probably a shared resource. That means that you collectively only get 100 requests per hour. However, if you provide an API key, which you can get from this page, you instead will get access to 1,000 requests per hour for that API key alone. And so as a result, by signing up to get an API key, you get access to a much higher level of requests that are yours to spend independently. So we highly recommend using an API key whenever you're making requests against the new services. The endpoints that we're discussing today, meanwhile, all have their own separate homepage at this OGC API/V0 path. We'll talk a little bit more about that V0 in a bit, but first I want to point out some of the useful links off of this homepage. First, on the right, you'll notice that there's a box that says documentation. This contains a link back to those long-form tutorials that I discussed a second ago, as well as a link to our reference documentation. It's our Open API-based Swagger UI page that provides more at-a-glance documentation for developers. The other thing to notice is that the middle of the page contains cards, which lead to each of our available endpoints. If you click through the link that's on all of these cards, you'll make a small query against our APIs and get the results from that query displayed in a nice page with an HTML table that looks like this. By default, when you're accessing these APIs from a web browser, you get this HTML format back to hopefully help you interactively build queries and see your results in a nicely rendered format. If you access these APIs from anything other than a web browser, you'll instead get the JSON representation of that same data. If you want to make sure that you get a specific format, you can specify it using that F argument. So for instance, the link I have here has F equals JSON. And it's important to note that the JSON format is our authoritative format for our API responses. Other formats might not include all the information that the JSON response does, but the JSON response will always have all of the information included in every other format. Right now, in addition to our HTML and JSON responses, you can also pass F equals CSV to get a CSV download of your results. Now, you might also have noticed on this slide a next link located under the map on the bottom right above that table. That next link is also present in our JSON response as a link with a relation type, that rel element of next. These APIs use pagination, which means that if your query returns more than a certain number of rows, your response is going to be split into multiple pages of data, which you need to request separately to get the full data set. This next link is how you know if there's another page of data to download. If you have a next link in your response, there's another page. Once you have no more next links, you've downloaded the entire response. Two things to note is that first, the default size for a page is set to be 10 responses in order to make that HTML table render nicely. You can, however, set a limit argument with any number up to 10,000 responses per page. And for most people, we recommend setting it to 10,000 results. That will decrease the number of pages that you have to walk through, mean that you're querying us fewer times. And so long as you're not on a slow internet connection that might time out downloading that much data, it should help you make more efficient queries over time. The second thing to note is that we do not currently have a good way to include next links in our CSV downloads. We're working on a solution here, but for the time being, if your CSV has the same number of rows as your limit argument, it likely means that you haven't downloaded the full result set yet. And so now I want to talk about some of the exciting features of the new APIs. I'm going to start off with smaller features that maybe only I'm excited about, and then end on one that I think is of pretty broad interest. First off, I mentioned earlier that the API URL ends in v0 here. That's because we consider our current version of these APIs to be our v0. We're still adding features and endpoints that we consider to be core to our final modernized system. Once we've released those features and endpoints, we intend to add or release a v1 of these APIs. That v1 will run in parallel with v0 for at least 6 months before the v0 is decommissioned. Now, at that time, we might also make some small changes, like adding spaces to field names or changing data types of fields, things like that. It's going to be much smaller changes than the change from water services, but we're saving those until this transition to v1 to make sure that any query you're running against v0 won't break while it's running against v0. This versioning means that we're going to be able to release new features and those necessary breaking changes gradually, giving you plenty of notice and the ability to migrate over without having to scramble to do things as soon as the change drops. This wasn't something that we were able to do with water surfaces, and so as a result, we sometimes had to make changes to that system without first having a viable alternative available for you. So I'm really excited this is something we're baking in from day one here. A second new feature is that these APIs are built to be flexible. Now that means that you can make very flexible queries to determine exactly what data you want back from an endpoint, but also you can determine what fields you want the API to return. So here, for instance, I'm returning just the value and time fields from our daily values endpoint. This might be useful if you're, for instance, querying a single time series where you already know all of the monitoring location and parameter code metadata that you need. As such, querying for just a few of these fields seriously slims down the size of the response object, which means that I'm able to download it much faster. This can be really useful for performance-sensitive applications. For instance, if you're developing a web application or a live map, this might make it so that you can access services directly for the data you're looking for and not have to think as much about caching layers or alternate databases or other solutions like that. And then last but not least, because we're using this OGC API feature standard, you can also access data from these services directly in GIS systems. For instance, in this image in QGIS, I've written a very, very small amount of code, just the desired filters I want, and can use that to query our APIs for here it's the most recent day of mean gauge height measurements across our entire observational network. If I hit OK and then add this to our map, I can get all of those measurements locally in my QGIS instance. Because this is in QGIS, I can then save this out to file and use it in other analyses or email it to someone. This has been our most requested feature for years, and I'm so excited it's possible with these new APIs. We have a tutorial online for accessing this data from QGIS. We are hoping to develop one for Esri products, but frankly, I just don't have the experience to write it myself, so it's a little bit slower going than the QGIS one was. And so before I hand things to Elise to talk about our computational tools, I just want to talk about the timeline for our services and when you're going to need to migrate over. We currently have a number of endpoints available. That includes our daily values endpoint, replacing DV, time series metadata and monitoring locations, which together replace site, latest continuous, which provides the most recent measurement from our IV service, and a number of lookup services like parameter codes and HUCs and other data types like that. We additionally just released a field measurement service, which partially replaces the measurements page on NWIS as well as the GW levels endpoint from water services, combining field measurements of surface and groundwater in a single place for, I think, the first time in our delivery history. We are currently working on releasing a replacement for the IV service, which will be called continuous. And then we'll be continuing to release additional endpoints, including proper APIs for our peaks and ratings pages, hopefully in winter of this year, early spring of next year. If you have a use case that can be met by any of the endpoints which are currently available on OGC API/V0, we highly recommend that you look into migrating your workloads over as soon as practical. We do not intend to decommission water services this year. And when we do intend to decommission water services, we will have very clear communications with clear dates available. However, we do expect that there may be some performance degradation to water services due to changes in our hosting environment, which mean that if you're able to move over to modernized services, you will avoid those potential degradations and maintain access to data through any incidents that might happen. So we highly recommend migrating over as soon as the data you are looking for is available from the modern system. Now, I know that a lot of folks are going to be waiting for that continuous endpoint to be available. And if that describes you and your use case, I highly recommend taking a look at the daily endpoint. It's not the same data, so I'm not saying migrate to daily, but the daily values endpoint has the exact same fields as continuous does and is shaped the exact same way. And so if you look at how you would migrate to use the daily values endpoint, that will inform how much work it's going to be to migrate to use continuous once it is available. So that might save you time in a migration once continuous is released. My last note here is that we do not intend to release V1 of these endpoints this year. I mentioned that when V1 is available, we'll be giving at least 6 months of notice before V0 is decommissioned. But I just want to highlight that that's not happening in the immediate future. And so we're not asking you to migrate and then immediately migrate again. The other thing to note is that changes between V0 and V1 will be much smaller than changes between water services and the modernized endpoints, things like adding a space to a field name. But even then, we will give you many months to move over to the new system. And so with that, I'm going to hand things over to Elise to talk about some of the changes coming to our computational tools.
Thanks, Mike. So as part of the computational tools team at the USGS, I'm now going to walk you through how these API changes will affect the set of R and Python packages we maintain. Next slide. So let's start with the data retrieval packages, which are super helpful for pulling water quantity and water quality data into a programming environment. We have created analogous packages in R, Python, and even Julia. On the back end, these packages are doing a lot of the work of building the web service calls for you and processing the response objects into tabular data sets for further analysis. Next slide. So here's a quick screenshot of what data retrieval in R returns when making a DV call using the function read_dv. Hit next. And here's what the same call looks like in Python using the getDV function. The point I want to make here is that both packages return very similar data frames with a date column, a site number column, and a separate column for each parameter code requested. And this is showing the legacy water services. Next slide. With the new services coming online, the computational tools team is hard at work creating new functions to accommodate these changes. We have started developing these functions in the R version with data retrieval Python following suit. So that one's in development right now, and hopefully we'll have new functions very soon. Here's what some of the new functions look like that are available right now in R. On the left-hand side of the table, we have existing functions that use the legacy water services API to pull water data. For example, read_dv is the function used to pull daily values from the legacy water services API. But on the right-hand side of the table, we have their eventual replacements with read_water_data_daily being used to pull water data from the new APIs Mike described. Note that we're in a period of overlap where both the old and new functions will be available for use side by side, but eventually the functions on the right will replace the functions on the left. Next slide. So let's pause for a moment on a comparison between read_dv and read_water_data_daily, currently in development. Similar to Mike's slides earlier, we can see that not only will the function name change, but the input names and parameterizations of those inputs will change a little bit as well. For example, read_dv expects a string of numbers to represent the site numbers input, while read_water_data_daily will have an input called monitoring_location_ID that takes the agency name and the string of numbers separated by a dash. This ensures the user's call will return a unique monitoring location, since it's possible for multiple agencies to have the same site number. Now, the parameter code input looks almost identical with slight change in the input name, but what I want to note here is that read_dv returns each P code as its own column, also called a wide format. Whereas read_water_data_daily, on the other hand, returns a flattened or a long format, where if you were to request multiple P codes worth of data, each value for each P code would show up in its own row, defined by a date, site, and P code. If you want to try out these functions as they come online, well, actually, quite a few of them are already available in the CRAN version of data retrieval. But I also suggest following the develop branch on our data retrieval on GitHub, because that's where new functionality gets its soft launch and you can see what's coming online. Next slide. So thus far, I've focused on the data retrieval packages, which are used to pull data from water services and soon the water data, or not soon, currently the water data APIs. But I also wanted to make mention of another set of packages we maintain. In particular, HiSwap in Python and HASP in R. Both of these packages work seamlessly with water data obtained using data retrieval and are used to place surface water and groundwater into a historical context. If you're not familiar with them, you should check them out. Next slide. So of particular interest, these packages, particularly HiSwap, possess many of the same calculations and capabilities as the soon-to-be decommissioned WaterWatch web pages. Click next, Mike. HiSwap's documentation, which is available on GitHub, includes a set of example Jupyter notebooks that walk the user through recreating some of the visualizations seen in WaterWatch, like the statewide streamflow condition maps. Currently, the example workflows for HiSwap and HASP refer to legacy water services, like the read NWSDB and getDB functions. But as we develop new functions that work with the new APIs, these packages will also be maintained and adjusted to include examples leveraging these cutting-edge data acquisition functions. Next slide. Finally, we recognize there's a lot of change coming your way, and I just want to point out that the Water Data for the Nation blog has a wealth of information on this transition, including a post about converting data from long to wide format and back the other way. Additionally, Laura DeChico, who's the lead developer of data retrieval in R, has put a ton of effort into creating high-quality documentation for using data retrieval, from individual examples on how to use each function to more extended workflows that not only pull data, but analyze and visualize it. This continuity will be maintained for the new functions coming online, both in R and Python. As resources allow, we would also like to provide trainings on making the switch with these computational tools. So if you're interested, please reach out to us. I think our email will be on one of the final slides. And with that, I will hand it back to Mike.
Yeah, thank you. So I've just got two final thoughts as we wrap up our presentation here. So first, as we've mentioned, we're working on modernizing all of the tools and services that are available for accessing USGS water data. If you're interested in this progress, you can find more information about many of these efforts at our new homepage for Water Data for the Nation at waterdata.usgs.gov. And then last, but certainly not least, I want to say that we recognize that the transition to these new services is going to be a big change for a lot of people, and we want to make sure that we're here to help. So please feel free to reach out to any of these emails if you need assistance with anything we're talking about today. On this page, we have three primary emails. The first one here, gs-w_waterdata_support. It gets hidden by the underline here. That email is the best place to contact if you are having any challenges with using the new services. The team who watches that inbox will be able to help you debug your code and help you get started using the new services for your application. The second email, wdfn_usability testing at usgs.gov, is the email to reach out to if you're interested in helping us with user testing. We really appreciate getting people's input on the products that we're releasing, especially folks from further aflung than necessarily just the folks at USGS who know how to email me. And so it's really, really useful for you to reach out to that email and say, yeah, I'd be interested in helping user test. We then might reach out and say, oh, we're interested in knowing what documentation is missing, what services are easy to use, what things are difficult to find, using that to inform our development and improve our products going forward. And then last but not least, as Elise mentioned, if you have questions about computational tools specifically, comptools@usgs.gov is going to be the best email to reach out to there for support. And with that, I want to say thanks, and I think we have time for the Q&A.
All right, thank you so much. We've had a few questions coming through the chat. Just a reminder, if folks have questions, to post them in the Q&A, but we'll get started here while folks are typing. So we had one question come through. Can graduate students looking at daily values at multiple site locations also request for API keys?
Yeah, so absolutely anyone can request an API key, and we think that anyone using these services should. So if you go to api.waterdata.usgs.gov/signup, you'll see there's the form there to fill out to get an API key. And this form then emails the key to whatever email you provide here, and automatically you should be off to the races. I will also note this box at the end here, how we use the APIs, confuses folks. We do not screen this. The key gets sent to you automatically. It is useful for us to know, especially if you have links to anything. Like, it's cool for us to see what people are doing with this data. Absolutely leave it empty if you don't want to answer.
Thanks. We had another question that Elise you already answered, but I'll bring it up here in case others have a similar question. I noticed that you removed the qualifiers, for example, capital P for provisional data from the download JSON file. However, this is a very important information in our work. How can I get such information?
Yeah, and so Elise mentioned this in the chat, but one change that is coming with these services, we're separating out what we think of as qualifiers from the approval status of data. So when data is initially collected, it's viewed as being provisional until it has a chance to go through a QA/QC process, which then is how we approve the observations. That information is now returned as approval status on all of our measurement endpoints. Qualifiers, which are things like this measurement may have been impacted by ice, this measurement is estimated but wasn't actually collected by a sensor. The sensor was dry when this measurement was collected, and so like this isn't a real measurement. That information is still returned in that qualifier field, but we felt it's meaningfully different enough from approval status, which every observation goes through, that we separated out the concepts.
Sounds good, thanks. One question in the Q&A, would you be able to post the link to the QGIS tutorial?
Yeah, Elise, would you be able to find that on the doc site for me? I can also pull it up here real fast on the slide. It should be at api.waterdata.usgs.gov/docs/odcapi/gis. We are continuing to build out our set of documentation on the site here. And so as we add more documentation, in particular, as we add the ArcGIS tutorial, which I have been told, I just saw the question come in, I have been told that it works well for everything but monitoring locations because we have a bug in that endpoint, but for every other endpoint, it works very well. I've been told that works. I haven't had a chance to sit down and relearn Arc enough to actually write that tutorial out. So that is coming. It will be in this docs folder here once we have that available. But I know that folks have used it with success in ArcGIS already.
Great, thanks. All right, another question. When do you think the Python functions will be ready? Is it a part of the update a parameter to include the unique API key? Is part of the update a parameter to include the unique API key? Sorry.
The answer to that one is yes, and hoping to have those functions available sometime this fall. I'm working on them as we speak, but they still need to get perfected and reviewed, but we're actively working on them and are going to have them out as soon as we can.
I really appreciate you guys sharing kind of your work that's still in progress with the community as a whole. I think it's really helpful for folks to see what's available now and what's coming down pike and not just everything all at once. So thank you for your willingness to do this and share with the community. An anonymous question, will there be a change in flagging for ice affected flow?
So effectively, no. The change that will come is that we aren't using abbreviations anymore. We're using words for qualifiers. Because it's August, I don't know that I have an ice example. Oops, I just sent that chat. I meant to do a paragraph. Example of a qualifier impacted site. So I just sent in the chat a link to an observation that has a backwater qualifier, which is one that we have examples of in our database right now. And so you should see the qualifier gets returned as an array, which is also a change now, is that these will be separated by commas when there's multiple qualifiers rather than just pasted on top of each other. But the ice one will look exactly like this, except instead of, I think it was a lowercase I in water services, instead of that, it's going to be all caps ice. But there's no change to what gets a measurement qualified as ice impacted or anything like that. It's the same information, just a slightly different display.
All right, no more questions have come through quite yet. We can leave it open for a few more moments if folks are thinking.
Yeah, someone mentioned that one of the GitHub links didn't work for them. I'm assuming maybe it was the data retrieval uh, develop branch. So I'm just going to share in the chat the general data retrieval repository on GitHub, and you can navigate to the develop branch from there. It's interesting because it worked for me, but I apologize that it didn't work for you.
Great, thanks. Okay, another question came in anonymously. Previously, you didn't used to show backwater flags. Are you going to update old readings with this qualifier?
This is such a comically complex answer, so apologies. For observations that are provisional with a backwater qualifier, oh, I can't remember. Folks on this call know this better than I do, I guarantee. I can't remember if it is just discharge or gauge height that is not masked, but other parameters are masked out. For the ones that are masked out, then we are going to be releasing the fact that it's masked out because it is backwater observation. So it will be labeled as backwater with a missing value there. Which I should also mention, one change from the legacy system is that the missing values are now going to be nulls rather than a stand-in value. Uh, for approved data, which has a qualifier such as backwater, we do not automatically remove these qualifiers. However, individual water science centers who are responsible for the actual collection of the measurements, who do the maintenance, who actually deploy the sensors and everything, a common practice, but not universal, is that when measurements are approved with a masking qualifier, the qualifier is removed. So unfortunately, that is not universal across the entire observational network. It really depends which regional office does the data collection and maintenance.
Perfect, thank you. Okay. Another question just came in. Will values that exceed a threshold that are currently masked, essentially deleted, be qualified instead so that a -9999 sends and not a gap in the timeline or time series data?
That's very interesting. I'm actually going to bring that back to our team because our current behavior is that it is essentially deleted. But I'm going to bring that back to our team. Thank you for the question.
Thanks so much. Okay, if there are no more questions, we can wrap up a little bit early here. Thank you all for joining. We had over 60 attendees for this webinar, so thank you for taking the time to join us today. Oh, another question. Can you keep the original qualifier with approved and estimated values if it's backwater, ice, etc. in future versions?
So that starts getting way outside of my domain, unfortunately. This starts becoming a question of data management among the regional offices. I can bring up that this is a desire with these groups, but I can't make any promises about how effective me bringing it up is going to be going forward.
That makes sense. All right. Well, a huge thank you to both of you, Mike and Elise, for taking the time to share this information with us today. For all of you joining virtually, this recording will be shared on the Quasi YouTube video or YouTube channel as well, in case you want to share this recording with colleagues or look back on this information. There's a few thank yous in the chat, and I'll extend that as well. Thank you so much, and have a good rest of your week, everyone.
Thanks so much.
Bye.